All right. Welcome to Anglo Nation South Asia, everyone. So happy everyone's here. So happy everyone could take out the time. And so happy that we have a very special guest, Craig Spence. Welcome and thank you for agreeing to meet with us and speaking with us today. So excited about your talk. And I think I've already made, it's really late already. I think people who wanted to join would have joined. So, Craig, the floor is all yours, and just you can
Cool.
start presenting whenever you're ready.
Awesome. Thank you. Let me try to get my screens all set up. All right. Let's do...
This is a sneak preview of an upcoming conference talk you're doing. We get like the exclusive, like before anyone else sees it. This is very
That's
exciting.
Yeah. So I'm speaking couple weeks now at the Reliable Web Summit, which is run by our lovely, I guess, the NGConf team.
Right.
And so we'll see how this goes. This is my first, this is the first people seeing it. So hopefully it is fun.
Oh, we love sneak peeks, and also when people practice on us. That's our favorite thing. Always encourage that.
Let me see. No. Oh my goodness. This one? Let's see if this works. If I get this wrong, it gets it wrong. But... All right, is that working? Hell yeah, it is.
Yeah. That looks awesome.
Thanks.
All right.
All right. I haven't done this in a while. We'll see how we go. All right. So, this is the sun. Over the next 8 billion years or so, it's going to grow and grow and grow and eventually consume the Earth. Tiny little changes will all add up and eventually destroy the entire planet that we call home. Little changes can have a really big impact over time. But quite frankly, there's enough scary stuff going on right now, and I'm personally quite overwhelmed by it all. So we're just going to chill for a little bit, and we're going to just talk about computers. So hi, I'm Craig, and much like the sun, I'm a super hot giant ball of existential terror. And like many of you, I have the privilege of writing software to earn my living. I'm from New Zealand, but I live in Stockholm, and I work on the desktop app and the web player at Spotify. In Angular GDE, I really love the web, and I really love helping teams build better software. I've been lucky enough to work on a number of reasonably large and old code bases, although I guess it's all kind of relative. But I've also worked in environments that espouse the ideals of Agile, pushing for incremental change and always shipping working software. I've worked with systems that are capable of massive experimentation to really understand the impact of product changes and with lots of user feedback. But despite that, I've been involved multiple times in big confrontational UI changes where there was no real going back, because incremental change is hard. And legacy software is also hard. Codebases evolve over time, and a mature system can be quite a powerful thing. There are significant benefits to the status quo. You really shouldn't underestimate the value of working software or having a known system with real users. Billion-dollar companies often exist on top of old code, that original prototype that became productionized, or the monolith that people have tried and failed to break apart, built up over years and years. And these systems are often quite stable until you try to change it. And if it's hard to change, that means that it's hard to fix bugs and hard to deliver new value to users. So there becomes a point where it's not actually a status quo, it's a gradual decay. And you can kind of wonder what the system might look like in 5 or 10 or 15 years. You can end up in a state where the codebase cannot be safely changed without making something worse. You've optimized for a current paradigm and reached a local maximum. A coworker once referred to a codebase as being in a state of accidental immutability. No matter what we did, something broke. There wasn't a safe path from where we were to where we wanted to be. But most of us have some idea of what we might want our codebase to look like. We can imagine this beautiful utopian state exists. but it might seem totally out of reach, either limited by time or money or whatever it is. Your current code base is what it is, and you've got to keep shipping stuff, and so changes have to happen, and so they often happen dangerously. Everyone wants a better way, and eventually maybe someone says, let's just rewrite the whole thing. And revolution is exciting. Everyone tries out bold new ideas, things are happening really quickly, making lots of progress. You're kind of unencumbered by the shackles of that old world. You can move really fast and break everyone's stuff, build new, better, shinier things. But that can also be super dangerous, and a lot of people can get caught up in the middle of you tearing apart that status quo. But sometimes revolutions are necessary. Sometimes the system is so broken that the best path through is to burn it all down and start again, and hopefully you do end up with something better. But with software, there are many, many cautionary tales of revolutionary change where it's gone all wrong. We always think it'll be different for us, though. In my experience, it inevitably involves scope creep and too many things changing at once, such as a full redesign and changing tech stack and this and that other thing. You might end up through the other side, but there's always a cost, whether it be money or people, or if you're not careful, precious institutional knowledge being lost. There can be tiny implementation details or important tests, version control history, those kind of things. Other times, some brave soul might go out on their own and attempt to make things better within the existing codebase. They make a new branch and start working away at fixing something. That can work for smaller changes, but what about for huge bits of technical debt? It's often hard to prioritize this kind of work, hard to do it all at once. And so trying to do a little bit at a time is a really good idea. However, that means that the branch might live for a long time, and merging that branch back into the main branch can be harder and harder. Sometimes there'll be communication problems and other people continue doing things in the old way while you're trying to move forward. To try to communicate their plan to the team, maybe this person decides to add a lint rule, but they've got hundreds of errors. And so they just disable it everywhere in the places that it currently fails. Or maybe they make a warning and then just everyone ignores it. People continue to do it in the old way and the decay continues. Sometimes it's possible to completely automate the change, which can reduce the pain of that communication breakdown. People might still do things in the old way, but that doesn't matter because you can automatically migrate their changes to the new way. We already use a lot of automation to do big improvements to our code. We might run libab to migrate from old JavaScript to newer syntax, or an Angular schematic to upgrade to a new version of Angular, or Prettier to make our code formatting more consistent, or a custom ES lint rule to fix some specific issue in our code. Some things can't be automated completely, but often you can get 90% of the way with an automated script and then tidy up the last little issues manually. But there are other things that computers do that we can also take inspiration from. An evolutionary algorithm is an algorithm that explores possible solutions using a heuristic method that is inspired by natural evolution. These algorithms reflect the process of natural selection, where the fittest individuals are selected for reproduction in order to produce offspring of the next generation. One specific type of evolutionary algorithm is called a genetic algorithm. There are two key inputs into a genetic algorithm. The first part is a description of the potential solutions to the problem. Each variable in a solution is called a gene, and all the genes are combined into a chromosome, which represents one solution to the problem. A number of potential solutions are collected together as a population. Determining what each gene should be is the main challenge here, as it requires the implementer to decompose the problem into all the variables that might impact the solution. The problem must also be described as a fitness function, which takes the chromosome as an input and evaluates the fitness of the solution. Each chromosome in the population is evaluated by the fitness function. Once the population has been evaluated, the selection phase begins again. First, the solutions are sorted by their fitness scores, and some weak chromosomes are terminated. Next, the crossover phase selects a number of genes to be shared between two parent chromosomes. Then the pairs of chromosomes combine to make new chromosomes until the population is back to its original size. Finally, some small number of genes within the chromosomes are mutated. Then the fitness phase starts again with the new population. And then it's selected again, and then so on and so on. Here's an example of a genetic algorithm that plays Tetris, if this loads. The game of Tetris is decomposed into a number of genes that might impact where a player puts the brick, such as touching the floor or creating a hole or clearing 2 lines. Chromosomes are made by assigning different weights to each of these factors. The fitness function of the algorithm simply plays the game with the given weightings for the chromosome, and then the chromosomes are compared by their final points total. At first, they really suck at playing Tetris, but over a series of generations, the chromosomes become better and better, very, very quickly becoming better at playing Tetris than me. There are, of course, a large number of problems that humans can't solve yet. Humans are currently still the winners when it comes to more creative or subjective endeavors. While a computer can easily find all uses of an old deprecated API, it can't necessarily tell which one of the shiny replacement APIs it should use to replace them. This is, of course, a field that's undergoing a lot of research right now. But what it ultimately comes down to is that humans are pretty good at breaking down problems. If you break a big problem down into a set of smaller problems, they can easily be solved individually. You may have some problems combining the solutions, but that's just another problem, which we can then break down and solve. And there have been a continuous movement towards building software in this way. Microservice architectures have become popular rather than big monolithic applications. Each part of the system can be considered separately and can be changed separately without impacting the whole. This is, of course, similar to component architectures in front-end code, where smaller components are easier to reason about and to change. Of course, this doesn't come without a cost, and you may introduce new communication problems and ownership problems. But the fact remains that building systems in this way allows for change to happen in smaller chunks and for the system to evolve over time. So wouldn't it be great to have a way to describe a change you want to make in your codebase and define what progress towards that final state looks like? We know what our codebase looks like now, and we know what we want it to look like. So can we break down the difference between these two states into smaller pieces that can be dealt with incrementally? We need a way to break down our codebase into quantifiable, countable pieces, much like the chromosome in the genetic algorithm. So it turns out there are actually many ways to represent our codebase. We just need to think about our code as data. Let's look at this little bit of code. What different kinds of data can we get from it? So first, there's the actual code that runs the program. But then there's the documentation as well. There's also some dependency information, like how our files relate to each other or the third-party dependencies they use. There's also type information about how data flows through the program. We can use various tools to read our codebase and quantify it in all different kinds of ways. We could count the number of files with a certain extension, or the number of circular dependencies, or the number of compiler errors. By quantifying these things, we can break the problem down from one big thing that needs fixing, into individual small things that can be fixed independently. But that's nothing new, right? It's just a slightly different way of thinking about it. But that's what TypeScript or ESLint or Jest or any number of other tools already do. What we need is a way to compare the quantified state of the codebase between two different points in time. So let's say we've run some fitness function over the main branch to get a representation of the state of the code. And then we've done some other work in another branch. We just need to run that fitness function again and then compare the two results. The comparison function has the job of working out if you got closer to your goal, if you got further away, or if you just stayed the same. The comparison function is going to act as a constraint, guiding your codebase in the right direction towards being better. That means that the result of the fitness function can actually be anything you like, as long as you can compare the results. But we can only have the codebase in one state at a time, so how do we keep track of the old state? It's actually become pretty common to store extra auxiliary information about a codebase in the repository. Chances are that somewhere in your codebase, you've got a dependency log file or a Jest snapshot file, or even an actual image for visual regression testing. We can use the same idea and store the current quantified state of the codebase inside the codebase. This adds one extra constraint to the result of the fitness function. It needs to be serializable so that it can be saved in a file. But it means we can always compare the current state to the last committed state. And so with all that, we have the 3 little pieces we need to enable gradual incremental migrations. And I've been working on wrapping this idea up in a new tool. I've been calling it Betterer. Betterer is a tool designed to make incremental improvement easier. You can think of Betterer kind of like a test runner, like Jest or Mocha, but the difference is that a Betterer test starts out broken by design. A Betterer test is a way to communicate your intention to other developers that there is something you want to improve in the codebase. You can check out the docs online or just run the initialization script in your project to get started. So let's dive in and see how it works. When we run that initialize script for us, it updates our package JSON to add a new little script, and it also adds the Betterer CLI dependency. It's also going to create an empty Betterer file, which is the entry point in your tests. It's TypeScript by default, but you can tell Betterer to use JavaScript if you prefer that. And that's actually enough Betterer to start doing its thing. Of course, right now it does nothing. There are no tests to check. But so what should a test do? It can basically be anything you want, as long as you can represent the result in a way that can be compared. Let's say I have a project that I want to convert from JavaScript to TypeScript. So let's write a test that counts the number of JavaScript files in a codebase. First, we're going to import Betterer test from Betterer and define our new test called migrate JavaScript to TypeScript. Next, we're going to write our actual test function. This is the fitness function that scores the codebase. We'll start quite easy. We're simply going to count up the number of files with a JS extension using the glob library. A number is nice and easy to compare, and it's also serializable, so that's good. Next, we need our constraint function, which does the comparison between test results. We're going to pull in the Betterer constraint result from Betterer constraints and return better if the new result is smaller than the expected result, same if they're the same, or worse if the new result is bigger. This is actually such a common constraint that you can just import smaller from Betterer constraints. You might also use bigger for some other tests. Now, if we run Betterer again, we're going to see something more interesting. We can see that our test migrate JS TS test got checked for the first time. So what did it do since we had nothing to compare against? Since we didn't have an existing result file, Betterer just runs the test and takes what it got as the base state. It serializes that result and stores it in a new file called Betterer results, which is basically just the same thing as a Jest snapshot file. Now we can run Betterer again, and this time that we'll see that our result is just the same. We didn't change anything in our code base, but Betterer found the results file and used that as a comparison point. This is fine. Nothing got worse, so we haven't gone backwards. To finish everything up, you just need to add Betterer to our build system. Somewhat ironically, this could be the last annoying branch you have to deal with. To get it working best, you want to have it run as part of your CI build with the CI flag set. That just tells Betterer that it should throw if there are any changes going on at all. It's also a good idea to run Betterer as a pre-commit hook, so you can check for any new issues introduced in your changes. You also might occasionally get merge conflicts in the results file, but you can always just take their changes. Even better, you can just run Betterer with the conflicts and it will resolve them for you. And with all that, you're pretty much good to go. So along comes the engineering manager on this project, and they're adding a new feature, and they haven't heard about our new plan to migrate to TypeScript. So they just add a new JavaScript file to their project, and when they try to commit, they get a big old error, and they can't move forward. So that's good for the state of our code base, but it maybe doesn't quite communicate what's going on as well as it could. So let's change a few things to make it a bit more clear. It's actually pretty common to want to have a test that targets specific files in your code base. So Betterer provides a really easy way to do stuff like that by using a file test. So let's try that out. The way you create a file test is a little bit different. It just takes a function with 2 parameters, file paths and file test result. Betterer can be quite smart, and sometimes it'll only pass you a subset of files to check, like if you're running in watch mode or if it knows that a given file hasn't changed. The file test result is an object that we will use to tell better about issues in a file. We also use the include method to tell better that we only care about JavaScript files. Better is also automatically going to exclude files that are excluded from source control. The body of this test is actually pretty simple. Since the test only targets JavaScript files, we just need to create an issue for each file passed to the test. To do that, we first need to read the file contents using fs, and then we call add file on the file test result object. We then call add issue on the file and pass the position of the issue. In this case, we're using 0 as the start and saying that the issue is 1 character long, which is going to attach the issue to the first character of the file. And this is also going to have a nice, helpful error message. So now we run it again, and it should be a lot better. There's way more details about going wrong. We've got a nice little code snippet in the error message, and we can also see that it's pointing to the start of our file and saying, please use TypeScript. And also pretty nice, if our engineering manager installs the Better VS Code extension, they'll even get nice errors in their editor. Now, so because our friendly engineering manager only gets like 15 minutes to code a week, they don't actually have time to fix the JavaScript issue. So they can use the update flag to force Betterer to update the results file so they can move on and make a PR. Sometimes you just have to make things a little bit worse to move forward, but this should really be a last resort. And we run it again with the update, and now our code base is back in a stable state, albeit a little bit worse than it was before. And of course, our EM loves it a lot and they love getting results, so they can modify the test and set an update for a deadline for when this migration has to be done. So there are tons of different things that we can apply this idea to. We could write a test for TypeScript if we wanted to enable a stricter compilation mode. We could use ESLint or StyleLint to introduce new lint rules or track to-do comments with a simple regular expression matcher. We can even lint other languages like Kotlin or Swift. This doesn't have to be a JavaScript thing. We could migrate React classes to React class components to function components, or turn on type checking in Angular templates. We could check accessibility violations with Axe, or we could check our code coverage with Jest. There's tons of possibilities. And Betterer actually comes with a few tests that are built in, which can help you get started. I'm sure more will come in the future, and since they're just functions, you can really easily publish your own. So, if you can't tell, I'm pretty excited by this idea. I've been working on it for more than a year now, and I still haven't lost any interest. But if this is exciting to you as well, and you'd like to come help me, please hit me up. I'm on the internet. We're probably not going to stop the sun eventually growing and swallowing the earth, but we might be able to make stuff just a little bit better. Thanks so much. That's me.
Thank you. I've never seen a dog that's more relatable than yours. And I love how it's so simple, but so powerful.
You haven't lost your touch.
Thank you. Yeah, I'm still pretty excited by it, so it is what it is.
Very professional.
It was. And you mentioned that there's some, like for StyleLint, ESLint, are those just like simple linting rules that you have in there?
So it literally just uses ESLint. So there's nothing extra there. It just takes the result of it and stores it in your disk, basically. So instead of throwing it as an error and stopping everything working, the first time you run it, it goes, okay, we've got 100 errors. That's fine. That's where we're at right now. And it will just never let you get to 101 errors. It'll throw an error if you add more. But if you fix some stuff, then it just keeps letting you fix them until eventually there are none.
So it basically finds what the state that you're at right now is like probably the base state. Mm-hmm. But what if you're improving on it so the better state becomes the new best state?
Exactly. So
Okay.
every time you fix a couple issues, it saves the new state, and then if you add new ones, then it throws an error again. So then the number can only go down if you want it to go down.
And so you don't have to tell it that the number is going down. Sorry, it'll know that the number is going. Okay,
Yeah, exactly.
that's cool. I really
Yeah.
like that.
Yeah.
I'm probably gonna start using it. Yeah.
Yeah, I've got a few people using it now. We started using it on some things at work. I've still got a few things to figure out in terms of really big code bases, but we're getting pretty close. So it's looking fun. Yeah.
Yeah, and this is especially gonna be helpful for projects that are trying to migrate to strict mode. And they have so many libraries, and they just want to convert it one by one, but they also don't want to like not have strict mode so that other people can add new libraries that don't have strict mode.
Exactly. That's exactly the use case. It makes stuff like that quite a bit easier. You still have to kind of drive towards it. Like, it's very easy to just end up staying where you are and not making stuff better, but it at least makes it impossible to get worse.
And Ankita's not just the host. She actually works on a pretty large team. So if she's actually using your library, you might get some good beta testing and feedback from that too.
I would love that.
Yeah, and I think I'm definitely going to push for this, because I think this is something exactly what we need to have for our very large code base.
Yeah,
So.
yeah. So like for reference, the code base I'm working on right now is 12 years old. Code base I was working before was 15 years old. You know, hundreds and thousands of engineers have touched these things. So this is a real problem that I keep seeing. Multiple companies where people know they want to make stuff better, but there's not enough priority put on that stuff. And so you never get the time to fix a whole big thing. So I was like, okay, well, cool. How do we fix a smaller thing?
Great. That's really amazing that you came up with this. Thank you so much. Does anyone have any other questions?
Hi, Craig. So this is a really good tool. Like looking at it, just seeing what it can do.
Thanks.
Just want to know, how do you come up with this idea? Like, what clicked in your mind to do something like this?
So this is just a thing that I've seen a ton of times. I think the best example I can think of with this is the old company that I worked at when I was back in New Zealand. We would pretty regularly migrate things in an automated way, right? So we would write a lint rule and then write a fix, and then we'd fix a bunch of those things. And that works really, really great. But then what happened is we radically changed how our buttons worked. From like just a design system point of view, we just had two different ideas of buttons. We went from having like kind of primary, secondary buttons to more like semantic meaning. So like a success button or a failure button, those kind of things. There was no way to automate that. Every single change in the code base needed someone to look at it. They needed a designer to go, okay, cool, this one should be that button here. And then we would do the update. And so what that meant was that for a long time, we had two different buttons existing in the code base at the same time. And people kept adding the old button. No matter how many times we told them, we were like, no, there's a new button, use the new button, design with the new button. They just kept adding the old button. And so what I wanted was a way to say, hey, don't use the old button, use the new button. Let's stop adding new ones, and then we'll eventually fix the old ones. But the tool didn't exist. And then I actually ended up leaving that company and moving to Sweden and took up my new job. And then I saw the exact same problem again. We would have all these ideas and we'd try to introduce a new lint rule, say. But what we'd do is we'd just disable all of it or turn them all into warnings, and then people would just ignore them. And so I wanted a way to do this where it was like, cool, this is locked in. You can only move in one direction. You can really clearly communicate what you're trying to do, and hopefully move towards a solution.
Yeah, that pretty much answers it, I guess. I think we are also, I mean, in my company also, we have the same exact situation. Like we have 2 instances of date picker, and even when we say, use the new one, like it doesn't work like that, even if you say.
No.
Yeah.
No. And so there are ways to do it now. Like, you make a big branch and you go through and you delete all the old date pickers. But you have to prioritize that, right? You have to actually invest the time and make a branch and then keep merging it, and then someone adds a new one, and it's just a pain. So with this way, you basically can get the rule into master, into main, into default, whatever you call your branch, as soon as possible. And then that's just locked in. So that's just your new state, and then you move forward from there.
Yep. Cool.
Very
And
cool.
did you say this is like an open source project or?
Yeah, let me link you.
Yeah, I was gonna ask
Shut up
if
and
you
take my
share
money.
all of the links.
I'll tuck my slides up as well, because that's always a good idea.
Yeah, no, I was only asking for me to share this with my team, but all right.
Sorry, just trying to. Don't know how to use computers sometimes.
Also, how cool is his username, y'all? Phenomenal.
Yeah, phenomenal.
Honestly, it's exhausting. I regret it.
Greg, this is the thing. This was the first thing about you. As soon as I saw that, I was like, oh, I like that guy. And there were many more things after that, but that was the first thing that made me like you.
Well, I'm
Don't let it go to your head.
glad it achieved that, if nothing else. Yeah, obviously happy to take any more questions. Happy to accept pull requests and issues and all those things. I'm on Twitter. You can find me if anyone wants to share more.
Right on. Yeah. All right, I'm gonna stop the recording.